The last thing I want to do in this chapter is take a look at amortized loans. It's important to understand this because a lot of loans are set up this way. What is an amortized loan? It's simply one that is paid off in fixed periodic payments. So a great example of this would be a fixed rate mortgage. You make the same monthly repayment on your loan each month until the loan is paid off. Same thing is true with a lot of auto loans, even business loans, even student loans. So lots of examples of this. So it's important for us to know how they work. Okay, financial calculators and spreadsheets are extremely helpful for figuring this stuff out. So we're going to look through a simple example. Let's suppose that you borrow $1,000 and the interest rate is 10% per year, and you're actually going to pay it off in 3 equal annual payments. How do you set this thing up? How do you figure out how much you got to pay each month and how much of it goes to interest and how much of it goes to principal? We are going to actually do that. We're going to construct a loan amortization schedule. The first thing we've got to do is find the required annual payment. How much do we have to repay each month? Well, I can guarantee you that it's going to be more than $333. So it wouldn't be enough to just take this $1,000, divide it by 3, and say we'll repay you $333.33 per year, because we would be ignoring interest. If it was an interest-free loan, then yes, we could do that. But in reality, you don't see that too often. So how do we figure out the amount that would have to be repaid? It's pretty simple, actually. We put in 3 for the number of periods. We put in 10 for the percentage interest rate per period. We put in 1,000 or negative 1,000 for the present value. That's the principal on the loan. That's how much you borrowed. 0 for the future value. And then we solve for the payment. We compute the payment and we end up with $402.11. That's the amount that must be repaid each year in order to make sure that you retire the $1,000 loan balance in full. So it's pretty simple to compute that. Now let's see how to construct the amortization table to show that in fact everything does pay off as scheduled. Well, let's do year 1 first. Alright, step 1 is to find the interest that you would owe in year 1. This is pretty easy. How much did you borrow? $1,000. What was the interest rate? 10%. So what's 10% of $1,000? I guess that would be $100, right? Okay, so that's how much you owe in interest the first year. The next step is to find how much principal you repaid on the loan. Well, that's not too hard either. If your payment was $402.11 and you paid off $100 in interest with that, how much was left to go toward principal? I guess that would be $402.11 minus $100, or $302.11. So you paid off $302.11 of the actual loan balance. So then the next step is to find the ending balance. How much do you owe after year 1, after that payment? Well, you take the $1,000 you originally owed, subtract off the $302.11 that you repaid, and you get $697.89. Repeat those steps for the remaining years. $697.89 was the ending balance as of year 1. Well, that becomes the beginning balance as of year 2. You still have the same payment, but how much is interest this time? Less of it is interest, right? Because 10% of $697.89 is actually only $69.79. Since you made the same payment of $402.11, that means more of that payment could go toward principal. So you paid off $332.33. And of course, if you take the beginning balance minus this principal that you repaid, you'll get an ending balance for that year of $365.56. Bring that forward to the next year, there will be even less interest on that, only 10% of this amount, so $36.56, leaving this much to go toward principal, and that just happens to wipe the loan out completely as of the end of year 3. Okay, hopefully you see a pattern going here. Even though the payment is the same on this fixed rate loan, it's the same per year, the amount of the payment that goes toward interest is declining. Less and less of each payment progressively goes toward interest expense, whereas more and more of each payment goes toward actually paying off principal on the loan. Here's a graphical depiction of that same thing. It's the same $402.11 that you're paying each year, but less and less of that progressively goes toward interest, whereas more and more goes toward actually paying off the principal. Okay, now I want to work an example problem that's just a little bit different, because most amortized loans are not repaid annually, correct? Most of them are repaid by the month. So let's do an example of an amortized loan with a monthly repayment. This one comes from your homework, and it's this problem. You want to buy a car, and a bank will lend you $20,000 to do so. The loan will be fully amortized over 5 years, which of course is 60 months, and the nominal interest rate will be 12% with interest paid monthly. By the way, this is probably not such a good idea. In practice, I don't know that I would advise somebody to borrow $20,000 on a car and pay it out over 5 years, especially when the interest rate is 12%. But let's see, for the sake of working out the example, how much the monthly payment would be in this case. All right. Well, let's go to our time value of money solver. We're going to start by pressing second and clear time value of money. Then we're going to put in what we know and ask to solve for the payment, which is the unknown. First, we have to keep straight what the periods are. Are we talking about years here? Well, actually no. We're not talking about years. How often do the payments occur? Monthly, right? So we should be thinking in terms of months, not in terms of years. All right, if that's the case, then what's the value of N? This is a 5-year loan, but N is not 5 because that's the number of years. We need to be counting months. There are 60 months in this problem. 60 is our value of N. What about the interest rate? Some people would put in 12% here. Those people would get the problem wrong though, because 12% is an annual rate. It's the nominal rate. In reality, we should be looking by the month here. If the nominal annual rate is 12%, what is the monthly rate? Well, it's that divided by 12 because there's 12 months in a year. So it would be 1% per month. Okay. Next, we put in the present value as the amount that you borrow, $20,000. And we leave future value alone at 0. Then we compute the payment. The answer is $444.89. Okay? So that's how you would compute the monthly payment on an amortized loan. Now before we leave, I want to look at one other problem that I frequently assign for homework, and I always get lots of questions on it. So we might as well address the question right now. This homework problem is about paying off credit cards, or really paying off any type of loan. Simon recently got a credit card with an 18% nominal annual interest rate. He goes out, buys a new stereo for $350. The minimum payment on the card is only $10 per month. Let's assume that Simon makes no other charges on the card. So he has realized that this was a bad thing to do, and he resolves to make no other charges on the card, and he's going to begin paying off this stereo, this $350 debt. Question A is, how long does it take for him to actually get that paid off? Let's see. Second, clear time value of money. This time we're solving for n. We want to know how long. I guess we should ask, first of all, what are the time periods again? They're months, right? We're talking about monthly payments. So clearly we need to be counting months, and we need to be using monthly interest rates. So we're solving for n, the number of months. Let's move the calculator over here for a moment. What's the interest rate per period? Don't put in 18%. That's the annual rate. You've got to divide 18% by 12. That is the number of months in a year. 1.5% per month is the rate you should be using. Okay, the present value is the amount you borrow. As before, that's $350. And then the payment, well, $10 per month, right? And we're going to put that in with a negative sign. When you borrow the money, it's like the credit card company is giving you the $350 today. But then, of course, you have to give them back $10 per month in this example. Future value we leave alone as 0. Now we compute n, and we find it's going to take him 50 months to repay that debt. 50 months for a total of $500 in total payments. Okay, there is another question of what happens if he kicks the monthly payment up to 30, and the answer is that's better, okay, because if I change the payment to 30, of course with a negative sign on it, and I recompute the number of periods that will take, it'll be only about 13 months. 13 months times $30 a month is about $390 in that case. So how much more in total payments does he make? Under the $10 a month plan, he's making $500 in total payments. Under the $30 a month plan, he's making only $390 in total payments. And that is a big difference. Remember, anything in excess of the $350 is interest. So the $10 a month plan, he's actually paying a total of $150 of interest on that stereo. Whereas the $30 a month plan, he's only paying a total of $40 in interest approximately. Okay, and then of course the best plan of action for something like a stereo, which is far from any kind of necessity, is to not use a credit card to purchase it in the first place and only pay cash that you had saved up for that purpose.